Oh, thank you so much. First of all, yeah, I will give handout. Okay, let me start. First of all, I'm really thank you for, especially you two guys. I know you are really stressed, with final presentation, and I'm really sorry for using your precious time. Okay, but yeah, you guys will do well in presentation festival. I guarantee that. Yeah, you can. Yeah, you are you are be the winners.
Yes, thank you. So helpful.
Okay. Yeah, today I'd like to talk about nuclear energy. Nuclear energy. First of all, my goal of this lecture 1 is make students understand the basic concept of nuclear energy, especially that what nuclear reaction is and what are uranium and plutonium. Okay. I've divided my lecture into 3 parts. First of all, concept of nuclear energy. Secondly, uranium and plutonium. And last section is why do we use nuclear energy. So let me start. What is nuclear for you guys? What is your image, or what comes to your mind when I say just nuclear?
Bomb.
Bomb.
Dangerous.
Dangerous, yes.
Radiation.
Radiation, oh yes.
For me, it is important part in cell.
Oh, yeah, good student, good student. Yes, it's a
Biotechnology.
yeah. In biotechnology, yeah. As Edwin said, it's an important part of a cell. And also in chemistry, chemically, nuclear is also one of the important parts of one atom. Do you know what atom is? Yes, and I will talk about the atom more specifically later. Okay. And then, what is nuclear energy? What is nuclear energy?
Energy which is from
Yeah. Definitely it's right. Yeah. Oh, good student, right?
I can present.
Yeah. Okay. Don't tease me. Okay. Okay. It's the exact definition of nuclear energy. Thermal energy, which is made by nuclear reaction. You know what thermal is? Thermal means heat type energy, which is made by nuclear reaction. It's the same as heat type, and yes, more I pretend to be professional, so I put that. And in this definition, the nuclear reaction is the key word. Actually, in other energies, the previous thing, the thermal energy, which is made by something, is the same. Like in solar or in fossil fuels, in wind, the same. Everything is thermal energy. Especially the difference is that nuclear reaction, and we will talk about the nuclear reaction today. Okay. basically there are two types of nuclear reaction. One is fusion and the other one is fission. Let me explain them briefly. I said atom a few minutes ago, and fusion means there are two different atoms, and then those two atoms combine. That reaction, we call that fusion. And fission is the opposite reaction. One atom split into two atoms. That's fission. You understand?
Yeah.
Yes. And both of them, as a result of both of reactions, we can get energy. That's the key point. So let me show you two videos that can be helpful to you to understand those fusion and fission. And before showing that videos, I want to tell you about one thing, the realistic thing. We, in a nuclear power plant, when we make nuclear energy nowadays, we only use that nuclear fission. I will talk about that later. And then, so today I will talk about the fission only, specifically. So I will skip that fusion part after showing one video. So please watch that video carefully. First of all, it's a fission.
So as you can see from the equation, one neutron combines with uranium-235, forming an unstable compound nucleus, uranium-236.
You don't have
This
to pay attention
unstable
to this.
nucleus splits into two stable nuclei, barium-141 and krypton-92. In addition to these two nuclei, 3 neutrons are also emitted, as well as a high amount of energy, denoted in the equation by Q. Since uranium-236 emits 3 neutrons in the reaction, these neutrons can be absorbed by other uranium-235 nuclei, resulting in a chain reaction. This leads to exponentially high amounts of energy being released by a single reaction. So, in this video, we've covered that nuclear fission reactions result in massive amounts of energy being released. Now, these nuclear reactions...
Okay, next one is fusion.
Nuclear fusion. In this video, we're going to understand how 2 or more nucleons merge or fuse together to create something more powerful and meaningful. So let's start by talking about the word nuclear fusion. Nuclear means the process which involves the nucleus, and fusion in English means 2 or more entities coming together or merging together to form one single entity. So, nuclear fusion can simply be defined as the fusion or combination of nuclei. Scientifically, nuclear fusion can be defined as a nuclear reaction in which lighter nuclei are combined together to form heavier product nuclei with the release of enormous amounts of energy. For example, lighter nuclei such as lithium and helium, when combined together, form a heavier nucleus. The mass of the heavier nucleus is less than the initial reacting nuclei. The word heavier here is phrased in terms of energy release, which is usually very enormous rather than mass.
Okay. So we saw that both of nuclear reactions. And I want to talk about the uranium and plutonium. And then after that, I will adapt those things into nuclear reaction. Okay? Yeah. First of all, uranium and plutonium are ones of the chemical elements. Yeah. Do you know that table? Have you ever seen that table? Everyone knows. Haven't you ever seen that table in a middle school or in a high school? It's just
You're not good
those this table shows the chemical elements we found. So yes. yeah. And then uranium and plutoniums are ones of that chemical elements, and those elements position in that part. And then before talk about the uranium specifically, I want to teach you that atom structure first. Yeah, are you following me? Okay. Okay, in a handout, you can see the structure of atom. It's an atom structure. We call that plus neutron. Then you don't have to memorize those words. And then this minus, we call it electron. And this big one, so it doesn't have any thing. We call it neutron. So it's an atom, and then we were talking about the nuclear fission, right? So, and I told you that fission is one atom split into two atoms. Can you remember? So, and the important thing is that when this original atom splits into two atoms, those atoms are totally different. The atom 1 and atom 2, they have different characteristics, totally different material. And as a result of that fission, we got energy. And how can it be split? To split that one atom, one neutron, this is neutron. When one neutron hit an atom, it can be split. Can you understand? Yeah. If you guys have a question, yes, anytime, anything you can ask me. So, in this atom, let me say this is that atom, and then one neutron came and hit this atom, and then this original atom can be split, like atom 1 and atom 2. Okay.
So let me just ask a question then.
Yes.
So when the atom splits between atom 1 and atom 2,
Yes.
you have atom 1, atom 2, but you also have something else, energy. Is that correct?
You mean does that atom have
When
energy?
the first atom
Yes.
splits into atom 1 and atom 2,
Yes.
there's also a third thing that happens, and that's, I guess, invisible. That's the energy. The thermal
You mean
fusion.
in the
Thermal
thermal
energy.
type energy?
energy, yeah.
Actually, I couldn't get
You don't understand
Sure.
what I'm saying?
Yeah,
Okay,
point.
so when the atom splits,
Yes.
you end up with three things happening. You now have two new atoms,
Yes.
and you have energy,
Yes.
thermal energy.
Yes.
Okay, thank you. And then those atoms go on and they continue splitting the neutrons, and so more energy, energy, energy.
Yes.
Every time there's another explosion.
Yeah, I will make it specific,
Okay,
like adapting uranium into that part.
okay.
But to follow up,
Yes.
in my understanding, is that neutron that comes out.
Yes.
So nuclei, two nuclei are creating, and then one neutron pops out. Only one. But anyway,
Yes.
one neutron will go into another kind of uranium, and
Yes.
it's going to split again.
Yeah. So in fact, not only
Right.
energy, it makes several more neutron.
Neutrons.
Yes.
Right. Yeah. Not only one, but
Yeah.
many neutrons.
And do the neutrons seek out specific atoms to hit?
Yes.
Ha,
That's the
thank you.
point.
Okay, thank you.
So now just I wanted to teach that structure and that reaction generally, and then I will make it more specific with
Excellent.
uranium.
Excellent.
Okay, and so specifically in nuclear reaction, in a nuclear power plant, that atom is uranium and plutonium. Only those two elements can have a nuclear fission reaction. Other atoms, other elements cannot be splitted with that one neutron. Why? I will tell you. Yeah. Okay. So it's a uranium. Uranium is a natural resource. We can get uranium from the uranium ore. You know what ore is? It's a rock, like naturally rock from rock that we can mine that ore and then get some uranium. So we can get uranium from uranium ore, and then in natural uranium there are two kinds of uranium. One is uranium-238, the other one is uranium-235. Then in the whole uranium-238 accounts more than 99%. And uranium-235 accounts less than 1%. So surely it's really difficult to get the uranium-235. So let's look at that fission. Okay. As I said that whole thing is nuclear fission, and then this atom only can be uranium and plutonium. But unfortunately, not all the uranium can be the source of nuclear energy. I said that there are uranium-238 and 235. And then only the uranium-235 can be used the source of nuclear reaction. And can you remember that? Uranium-235 is really scarce, it's really difficult to get. And so, to sum up, we can use uranium-235 and only plutonium for using nuclear reaction. And also, I didn't put the data of plutonium, but plutonium is also a source of, it's a natural resource, but it's really scarce. It's even harder to get plutonium as natural resource. So but there's a sorry. But there's another solution. Even though we don't have enough uranium-235 and plutonium, but we can get plutonium from this reaction. That uranium-238 is not a useless thing. From uranium-238, we can make plutonium. We can get plutonium. Let's say that it's a nuclear reactor, and then there are uranium-235, 238, and many things. And in this circumstance, naturally, the uranium-238 becomes plutonium. Specifically, it's also neutron. When neutron comes to uranium-238, uranium-238 gets one neutron, and then it became plutonium following this process. So, as a result, we can use that uranium-238, 235, and plutonium. Everything can be the source of nuclear reaction. Okay, can you understand? Okay, thank you for understanding.
What is plutonium? Is it
It's a really professional.
proton? Is it?
No, different. It's a X-ray and then Y-ray, gamma, and then yeah. Do you wanna
No.
learn that? Yes, it's really complicated. For you, I will research about that and I will tell you in a class. So, and then, I just said that in a nuclear fission, not only energy, we can get more neutron from that reaction. And then this neutron works an important job. That neutron hit another atom, I mean uranium-235 or plutonium, and then hit them. Another atom, hit them. So, can you imagine that? This reaction happens continuously. So because of that, we call that nuclear chain reaction, like chain. When one reaction happens, tons of reaction happen continuously, like a chain. Okay, so far, do you have any question? Or can you understand? Okay. How about the reserves of uranium and plutonium? Actually, in that case, we don't have to talk about the plutonium. As I said, we can get plutonium from uranium-238. So just let me talk about the uranium. Uranium is natural resource, and it's one of the most plentiful and sustainable energy sources. Why? It shows the reserves of uranium, natural uranium, according to countries. And then overall, totally, in the world, there are 5 million tons. Officially, there are 5 billion tons of uranium. And then with that amount of uranium, we can use it for about 100 years. Yeah. 100 years. And then there's an interesting thing. Many experts alleged that one country has about 4 million tons of uranium in one country, but it's not included in that amount because it's unofficial. That country is really familiar to us, North Korea. Can you imagine that? The whole amount of uranium, natural uranium, is 5 million tons. But in North Korea, they're only that small country. I don't want to say that country to North Korea. It has 4 million tons.
Oh.
So totally, unofficially, there are about 9 million tons.
We have to conquer them.
Conquer them. But do you think that 100 years is enough?
No, it's not enough.
No, totally not. Yeah, but I said that it's a sustainable energy sources. The reason why I said that is that amount, that 5 million ton, only included that economically, economically feasible amount. We can use it. We can get them that amount of uranium immediately if we want. But there's a potential uranium in seawater. In the sea, there's a lot of uranium. It's allegedly there's about 5 billion tons. Yes, billion tons in the seawater. Yes. So with that amount uranium, we can use that uranium for more than a few thousands of years. Yeah. Is that enough? Yeah, a few thousands of years. Okay. So, sorry. So now, can you understand that nuclear reaction and then uranium, plutonium, and how it works and how it happens? So now, the whole thing is for what? What is the purpose of nuclear power plant? Energy, electricity. To get electricity. So let's see how we can get electricity from the nuclear power plant.
In a nuclear energy facility, a chain reaction of splitting atoms releases heat. This reaction takes place in the reactor. All reactors are used to heat water into steam. This steam turns a turbine that is coupled to an electromagnet called a generator. The generator produces electricity. While
To sum up that video, boiling water by energy from nuclear reaction. Yeah, as we learned, nuclear reaction is fission, and then the heat from that boiling water generates electricity. So from nuclear reaction we get a lot of energy, and with that energy boil water, and then with heat from that boiling water we generate electricity. Is it clear? Okay. Isn't there any weird thing, strange thing you think?
Why do they boil water?
그 수련. 그 수련. Okay, that's what I wanted. Yes, why do we have to boil water? Why suddenly? We already got energy. Actually, it's not a necessary thing. But realistically, we cannot make electricity directly. Because this technology is really delicate and then it's not well advanced yet. So, but it's also been developing steadily. So in the future, I hope that we can get electricity from the nuclear reaction or other kinds of the power plant get electricity because of that part, because of that boiling water, it really affects on efficiency a lot in a bad way. If we can get electricity directly, we can get more efficient energy. And then additionally, not only for that nuclear power plant, other kinds of plants like solar power plants and fossil fuel power plants, every power plant use the same process except this part. With the energy, they boil water and then get electricity. Yeah,
Oh, go ahead.
yes.
How
Good.
does boiling water work in the process? Like what kind of role in the process?
Yes, because the problem is, yeah, good question. The problem is with that energy, we cannot generate the electricity directly. But we have advanced technology to get electricity from the heat. So I mean that generator is only can be run by heat. Can you understand?
Okay. And is the water that has been boiled,
Yes.
the water that's left over,
Yes.
is it contaminated?
No. No. There's no contamination from that
In that
reaction.
boiling water?
And then, additionally, in a nuclear power plant, maybe you probably saw
Mhm.
that shape building. It includes water. That water the role of that water is really important because they keep supply water to the generator to be boiled from the energy, and then they can reuse that water because I said that they use heat, and heat can be transferred to water again. So they have that kind of system. So they don't use that. They use that, but they use that water continuously.
So it keeps getting recycled.
Recycle. And then there's no contamination in that part. Can you understand?
You mean keep using the same water,
Yes.
right?
Yes. But they need a big amount of water, and then it's really difficult to make it 100% reusing. So they need the water supply. So that's why usually the nuclear power plant located in seashore or lake shore, because they can get water easily. And also that water doesn't have to be like pure or should be specific water. They can use any kind of water. Okay? Is there any question or? Yes, okay. So far we learned how nuclear energy is made, and then how can we get electricity from the nuclear reaction. So now, why we use it? Why? And before talking about that, I will show you one interesting thing that, do you know how much we rely on nuclear energy? How much?
25.
25?
40.
40?
75?
75. Okay. For example, in South Korea, 40%. Yeah.
Oh, how did you know that?
In Sweden, 42%. And in France, fully 75%.
Oh.
Yes. Oh, great students. Even though we don't know about that nuclear energy, nuclear power plants so much, but we already rely on that nuclear energy so much. Isn't it so surprising that we already rely on that nuclear energy so much? And the reason why we use that nuclear energy a lot is efficiency. Do you know what efficiency means? In this case, efficiency means the amount of electricity generated per the same input. So easily speaking, more efficient, we can get more electricity from the same input, with the same input. Okay? So let me show you how nuclear energy efficient. This table shows that these statistics assume that if we have the same amount of fuel, like specifically like 1 kilogram of fuel, if we have 1 kilogram of hardwood or coal, heavy oil, and uranium, plutonium, how much electricity we can get? So, as you can see, that uranium with reprocessing and plutonium with reprocessing, we can get more than 5 million times, comparing to 5 million times of electricity compared to hardwood, coal, those things. It's really obvious, isn't it? But realistically, it's not. It doesn't make sense that we cannot believe that just literally, because you know that 1 kilogram of uranium and 1 kilogram of hardwood is totally different. The price is totally different. Yes, so don't be allured with that statistics. But the thing they want to say in this statistic is that source is really magical to make electricity, to make energy. So let's look at those tables. So considering the price of fuel and considering everything, this graph shows the price of electricity according to other kinds of energy sources. In the USA, for example, the nuclear energy is much cheaper than other kind of alternative energies. But the price of that energy, electricity according to energy sources, really depends on the place, the countries, because it really relies on the environmental conditions of those countries. How about in Korea? In Korea, nuclear energy is much cheaper than other coal, LNG, fossil fuels, and solar energy. And the last graph, this graph shows the price of electricity regarding considering that production price and global warming cost and other external costs. It also shows that nuclear energy is much cheaper. In that case, I can say that much cheaper. Cheaper means the cheaper, the more efficient. Okay. Secondly, nuclear energy is not picky. It means that the nuclear power plants shouldn't be located in a specific area. Like solar energy or wind energy, you know that solar energy can only generate electricity in a daytime. And also, the location is really important thing. But nuclear power plants can be located in South Korea or everywhere, and then it can generate electricity 24/7. So that's why, like South Korea or Japan, those countries which don't have, which are not beneficial from natural resources, have a lot of nuclear power plants. And secondly, that nuclear energy is not really dependent on natural resources. As I said, the whole process is running by one atom. Do you know how small it is? We cannot see atom. Impossible. So comparing to like fossil fuels, it's both of them use the natural resources, but totally different things. So far, yeah, we learned nuclear chain reaction. There are two kinds of nuclear reactions. What can Jun answer this question? There are two kinds of nuclear reactions.
Fusion and fission.
Yeah, fusion and fission. And then what we usually use is fission. And then the sources of the nuclear reaction are uranium and plutonium. Okay. Especially, I said that uranium-235 and then plutonium can be used, but uranium-238 can become plutonium. And then following this process, we can get electricity. Can you understand? Okay. So is there any question? Overall, yes. Thank you.
How can a company, country which doesn't have sea,
Yeah.
how do they use nuclear plant?
As I said before, that it's that location is advantageous, not an inevitable thing. They prefer that location, but they don't have to be in specific location.
You mean as long as we can get the water, it doesn't matter, right?
Yes.
For example, in Toronto, on Lake Ontario, a little further away from the city, not very far, near Scarborough, there's Darlington nuclear plant. There are many small nuclear plants that are located on water systems. It doesn't have to be the sea.
But because of the Ontario Lake, right?
Yep.
But
It has to be on a lake system. It has to be near a lake.
What if we didn't have an Ontario Lake here?
It would be then close by a strong river, a big river.
And any other questions?
As long as we can turn the turbine,
Yes.
can is that anything be okay? My I don't know. It's crazy thinking, but you know, just car's engine, for example, you have 4 pistons,
Yes.
and then you just need small spark or explosion. So if we have that kind of system, like giant, like car engine system,
Yes.
so we put uranium and then spark, you know, nuclear explosion, bam, 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 and then we can turn the giant engine turbines. You know what I mean?
Yes.
just like car engines.
You're talking about the nuclear reaction part?
Yeah,
or
yeah. So
generating electricity.
generating electricity.
In
So we
yes.
can use without water if we design
Ah.
a huge car engine type of generator.
Yes, but the problem is the price.
The price.
Yes.
Okay.
You know that battery engine,
Uh-huh.
it's not suitable for a big industry, big power plant.
Mhm.
So that's why everything is made based on that price.
Price.
Yes.
is it possible concept?
Yes, possible. It's possible. But
Isn't it exploding or?
because the generating part is separated from the nuclear reaction, so it's not related.
Yeah.
Any other questions? Okay. So sorry for saying that. Yes, especially you guys should watch this video. And in my lecture 2, I will talk about some realistic thing, because today's class was a little bit more kind of scientific class. I talked about atom, fission, fusion, and you can think that why do I have to know about that? But lecture 2, I will talk about the realistic thing. Is it safe, or how about like Fukushima, or why it happens, why we use it? I will talk about those interesting things. So for that lecture, watching this video, the name is Does the World Need Nuclear Energy? And 2 experts, they debate about that topic. It's really interesting. So after watching that, please think about your own opinions. Okay? Yeah, thank you.